Okay, I'd like to tackle counters. As counters, okay. If you think of a counter, just think of counting 0, 1, 2, 3, 4. We are counting, so right. So normally when you say count, it's very rare that we say count and then you start thinking of counting down. We don't say just count and then you're just saying 100, 99, 80, no, 98 and whatever. We start from 0, 1, 2. So normally when someone adds to a counter without saying which counter specifically, would normally be talking of what? Of the up counter. Okay. Let's talk of an up counter. We will have obviously what? A down counter. With an up counter, let's just take we've seen how D-type flip-flops were used for what? For shift registers. We've seen how okay uh okay, the JK flip-flops were versatile. They could be used as whatever we wanted. Right, then the D-type flip-flops, we said they were what? We said we use them for what? For counters. Now we dealt with another type of what? Another flip-flop which we said was the what? Was the T type. Now let me make it a little bit bigger to illustrate what I want to talk about. Let's make it a little bit bigger. Alright, let's take a 1 bit counter. Alright, a 1 bit counter can only count 0, 1, 0, 1, 0, 1. Okay, so how far you count, it depends on the what? On the number of bits. Alright, so let's take a what? A T type. We know that the T type is simply a what? Is simply, there is the input, there is Q, there is not Q. Obviously we've said we've got the what? Set and reset. Okay, now let's suppose now, okay, not Q, let's suppose now all we do is we say that if we what? If we have an input which is a clock, right, what will happen here is that T type keeps toggling each time. All right, keeps toggling each time, so it will keep doing what? It will start off, there is our clock. Okay, it will start off, let's say we reset it and it started off at 0. When it's a master slave, it will respond on the trailing edge, it will toggle another what? Another trailing edge, it will toggle. T-type, all the T-type over does is what? Is toggle. Alright, so now, so let's suppose that so what are we doing here? We are counting from 0, 1, 0, 1. So you can see that with the what? With the T-type, we will always be what? Be counting 0 and 1. With one T-type, we can only what? Do one two counts, 0 and 1. Now let's suppose I were to feed the output of the 1 to another. Now I've got what? This here would be our Q, right? Now then I will have an output Q, which we'll now call Q1, and then this Q1 now is feeding okay, let's do this, is feeding the next, but it's feeding what? The output is feeding the clock. Okay, the input T, so that we have what? Our Q, not Q. All right, what will happen now is, let's observe nicely, we have QT. All right, so what then happens is that if you look at the one, the second one now, Q2, the input of Q2, the T input of Q2 is not being driven by the main clock, it is being driven by Q as a clock. So it's like there's two different clocks. So we call that type of what? That type of counter an asynchronous counter. They are not in synchrony. Asynchronous, all right, counter. All right, so you have the clock there, the trailing edge of the 1 drives Q1, but now if you look, Q1 here, when it goes from what? From 0 to 1, this is seen as a leading edge. All right, but when the Q1 is what? Is now going to what? Down. It is, if the clock here, if the response here is the trailing edge of the clock, it means the response here must be the what? The trailing edge of what? Of Q. When Q goes what? When goes from 1 to 0. So what does it mean? It means that our Q2 would actually be 0. that it won't respond here, because this is seen as what, as a move from 0 to 1, which is actually what, a leading edge. And this is a T-type, it will not respond there. What will it do? It will pass that stay 0 there, so that we would have had a count 0 0, that's 0 1. Now if you look here, when this part goes from 1 to 0, and the Q goes from 1 to 0, now this is seen as a trailing edge, and this is when our what, this is when our Q2, this second flip-flop, will then respond. It will what, it will toggle at that point. All right, let's have a few more main clocks. I think with one we're only able to count 0 1 0 1, that's it. But here now you can see that this would have toggled up, okay, but now look here, this would toggle back down, and that's a trailing edge for the what, for the next one, so meaning that this one will also what, toggle here. All right, so remember that that one keeps toggling. It's a T-type. All right, so it keeps toggling. It will wait for another what, another trailing edge before it can what, it can toggle back down. Let's see what will happen here. This is seen as a what, when the Q goes from high to low, seen as a trailing edge. When Q1 goes from high to low, this one sees a what, a trailing edge, and it will what, it will thus respond. So there is a trailing edge again there, it will go up. Now let's look at this. This is as clock pulse 1, clock pulse 2, clock pulse 3, clock pulse 4, clock pulse 5, clock pulse 6. I want to go as far as clock pulse 7 to highlight what I'm talking about. 7, and I'll just leave it at the start of clock pulse 8 there. Now we know that this guy will keep toggling, because all it does is the T-type, all it does is what, is toggle all the time. All right, now this one here, however, it only toggles when it sees what, when it sees a trailing edge. So this is the trailing edge as per Q1. So let's look at this here. You have the count 0 0 0 1. It's 1 0 here. Now this is 1 1. So what do you see here? With one pulse you could only do two counts, 0 1, 2 to the power of n 2. Okay, and then with 2 you can count how many now? 2 to the power of 2, which is what, 4 counts, so which is the count 0 1 2 3. What does it do again after that? It resets back to 0 and it recounts, and there is 2, and there would have been 3. All right, so what do you see here? We see that let me probably have another clock pulse here and call it 8. Let's see what will happen here. That one only ever toggles when you see the trailing edge, the T-type will toggle. But this is a T-type also, and this trailing edge is that. So when you see Q1 changing from 1 to 0, it also sees what, a trailing edge, and it will toggle. Okay, what do you see? It was the count 0 0 1 1 1 0 2 1 1 3 0 0 0 0 1 1. So it keeps doing 0 1 2 3 0 1 2 3. So it's doing how many counts? It's doing 4 counts. So with one clock pulse we could only do 2. With only one we could only do 2 counts, which is obviously the counts 0 and 1. So one can only do those 2 counts. Two of them can do, now if you've got 2 now you can do 4 counts. And where do you get this? We get this from what? From 2 to the power of n, where n is the number of what? In this case, number of bits, but these bits are coming from what? From the flip-flops. So this is a number of flip-flops in this case. All right, let's suppose we had a third, just to illustrate what we're talking about here, to further illustrate, to probably, if it's not clear already, to make it clearer. Let's suppose obviously this will now be Q4. Now it is fed by, this is driving the clock, okay, and it's a master slave, it's a T-type. So when you're doing counters, we're using what? We're using T-types, right? Now obviously when we want to set or reset, what do, we have to have a common what? A common set and reset. Let's just remove this. So I started off with what? I started off with only 1. We saw how it was only able to do 2 counts, 0 and 1. We went to 2, and it's still there. We see how we were able to only do what? To only do 4 counts, 0, 1, 2, 3. And then now we are saying, okay, how about we get the third one. So let's suppose I want to move everything here one step down. Why do I want to do that? It's because I want to say, what is the reset? What does the reset do? With the reset, we are able to say, let's start our count. Okay, at any given time we want to reset. Let's suppose our initial count, maybe the Q4 had been a 1. Okay, at that point of resetting, that 1 would go to a 0. Okay, so then that there sees the leading edge, that Q2 is fitting that clock, so it doesn't say anything, so it will ignore everything all the way up to when Q2 goes from what? From 1 to 0, which is seen as a what? As a trailing edge, and therefore you know it's a T type, so it will just toggle. It will toggle. There's nothing happening on T2. T2 is constant, so nothing happens. This is a leading edge on T2 is going from 0 to 1. It does nothing. But when the Q2 goes from 1 to 0, then this toggles back. Okay, and what do we see? Let's look at the count. If we were 3, this was going to be the count 0 0 0, which is 0. That was going to be 0 0 0 all the way there, and you still have the count 0 1 2 3. But now we have 4, we have 5, we have 6, and we have 7, and it restarts again 0. Obviously, it will then repeat the sequence. So what do we see now? With 3 flip-flops, we're able to do 8 counts. 2 to the power of 3 is 8. We're able to do 8 counts, which is the count 0 up to what? Up to 7. All right. So this is what? This was 0, 2, 3. This here is what? 0 up to 7. So you can see that obviously when you've got 4 of them, you're going to be able to count all the way up to what? Up to 16. If you've got 5 of them, you're going to be able to count, no, not up to 16, up to 15. From 0 to 15, which is 16 counts in total. 2 to the power of 4 is actually what? Is actually 16. If you have 5 bits, if you have 5 of them, then you're going to be able to count all the way up to what? All the way up to 31, 0 to 31, because there's 32 counts, which is 2 to the power of 5 is 32, which is 0 up to what? Up to 31. But as you can see, the clock is not common. There's a main clock here fed to T, and then the other outputs drive the what? The clocks of the what? Of the subsequent ones. So therefore, this type of what of counter is called the what? An asynchronous counter. Okay, we're going to come later to synchronous counters, where basically we're going to take what? We are going to take our what call this, our clock is going to be a common clock. All right, that will be our synchronous counters. Let's look at while we're at this, let's look at how would we count down. Let's say now, instead of taking our clock from there, taking our clock from the Q, let's suppose we took our clock from not Q. Let's just take 1 and say, okay, if we were taking our clock from not Q, and what do we have? We have here our clock coming from not Q. Our clock coming from not Q. Alright. What then happens? Okay, obviously still with 2 pieces we're still going to be able to what? To do only what? Only 4 counts. With 3 pieces we're going to be able to do what? To do 7 counts. Let's check the clock. Let me move this a little bit. Up. Okay. Let me move this a little bit up, and then come and borrow. only the clock and the, yeah, just the clock. Okay, let me borrow the clock and bring it down here. No, this is still relevant there. What I will do is I will just take a copy of it and put it here. So now let's suppose I also borrow the reset. And I say, okay, I'll reset somewhere. Okay, now let's say on reset, let's say our previous count was, we have got Q4, Q1, Q2, and Q4. Let's suppose we were at the count 6, Q4. Let's suppose we were at the count 6, which is when we reset, we were at the count 6. 6 is actually what? 6 is actually 0 for Q1. It is 1 for Q2. It is 1 for Q4. Let's suppose this was our count. We know that we expect responses there. I want to illustrate something with this. Okay, I want to illustrate something with this. Let me have a ninth one. I already know it's going to be thing. You will see that I need a ninth one for this particular case. There is our 9. Now we know that this is our what? Unless we are resetting, our reset stays at 1. Now we reset there, so we have what? We have zeros all the way up to the what? Up to the first trailing edge. Now at this trailing edge, now what happens is that this one keeps toggling. Okay, this keeps toggling, so I can fill Q1 all the way, because I know with each main clock it will keep toggling. That's all it will ever do. It will keep toggling. Okay, so it will keep toggling. So now, then what do we mean? Then if this one here is changing from 0 to 1, that means node Q is changing from 1 to 0. Okay, so what we see is a leading edge now. It's actually a trailing edge for what? It's actually a trailing edge for the next one. Okay, for node Q. So we are looking for trailing edge. So this is a leading edge. It must be a trailing edge. So this will now toggle with each leading edge. This is a leading edge. It will toggle. Why? Because node Q is in the opposite state. Okay, we are driving the clock with node Q this time. So a leading edge on Q1 is actually a trailing edge on what? On node Q. So it will keep with every leading edge of what? Of Q, it will be a trailing edge for node Q. So let's look at, so obviously also in this case here, same thing happens when we have 0 to 1. Here is a leading edge for Q, but here it will be going from 1 to what? From 1 to 0. So that will be a trailing edge. So every time we see Q2 going what? Going up, Q1 not Q will be what? Will be going down. So here also this will be, since Q2 is going up, this will change toggle. This is Q, that's not right. We need to have a broken line. Okay, this here is a trailing edge. Nope. This is a leading edge. So when Q2 is on the leading edge, not Q is on a what? It's on a trailing edge. So it will come down. It will do that. It will keep that until another, what looks like a leading edge for Q2 is actually a trailing edge for not Q. Let's look at the count. This is the count 0 because we reset. From reset, it immediately shot up to 7. Okay, didn't go to 1, we went to the maximum count. Then what happened here is that it what? It went down to 6, 110. Now it went down to 101, which is 5. Now this is 001, this is 100, which is 4. This is 11, and that's a 0, that's 3. That's 010, that's 2. That's 100, that's a 1. That's 000. It is counted all the way down and shoots back up again. So what we have here, we have what is called a down counter. When we're fitting our subsequent T-type flip-flops with what? With a clock from not Qs, from the not Qs, we are actually having what? This was an up counter. Previously we had an up counter where we were shooting from what? From Q. We're driving the T's with the Q's, and now we're driving the T's with the what? With the not Q's, and this is our what? Our down counter. So it's very important to note how that little difference here made such a huge difference, right? So it's not appropriate. Here I was just showing you, even if we reset, you see that we'll have lost the count here, because we're not supposed to count. When we count, we don't count 0 then go to the top. When we're coming from the top, we actually start right there. So what we then do, we actually then say, okay, probably we shouldn't have reset here, but instead we should have what? We should have set. So when you're dealing with the down counter, we then focus on the set data, and it's no longer true therefore to what? To say it will start with the what? With this count, but it will start with the what? With the maximum count. So what we then do is just move I don't see why. Control Z. I want to move this whole sequence here. Okay, so what we then see is that obviously now it's going to look a little bit fake. Why? Because our clocks are not similar in size. So then this would have been right, that would have been right. That, however, tends to be a little bit. So let me probably move it a little bit in. Well, it's not working, but the plan is this is supposed to be 1. This is supposed to be set. It goes up to high. Okay, and then from going up to high, everything keeps coming down with it what? With each clock pulse. Alright, so probably it needs to be a little better than what it is now. Okay, so what do you see? We see that these would have come and toggled right there, and these would have what? This is a what? A leading edge, so it would have ignored that. This is nothing happening, so this would have been down to 6, right? So we would have had the count 7, 6, 5, 4, 3, 2 1 0 back to what 7 6. So it will keep repeating as long as you what. So what we have here is giving us 8 counts. What are the counts? 7 all the way up to 0 and what, and restarting. Why? And restarting at 7. Why? Because it is a what? It is a down counter. We fed our what? Our clocks with the what? With the NOT cues. So these are our synchronous counters. Those are the what? The basics. I hope they made sense. If we were to put it in a table format, we would have our Q4 in a table, Q4, Q2, and Q1 with an up counter. It will start from 0 when we what? Fitting with the what? With the cues. When the clocks were fed with the cues, it will start from 0. This is for the up counter. Okay, 0 1 2 3 4 5 6 and 7. Okay, that would have been with what? With an up counter. However, with the down counter, it's the other way around. It will start from the what? From the maximum count. Oh, okay. I would need to clean up that mess. Okay, like this. Okay, so basically we have what? We have our T flip-flops as what? Used as what? As a alright, so now I can bring this one down. With an up counter, that's what we would have. With a down counter, I don't know, my software is misbehaving a little. With the down counter, we would have had down counter. You would have had the count Q4, Q2, and Q1. We set it all the way up, and then it starts to count down. And the what? The 7654. The clocks are fed by the what? The NOT cues. 2 1 and 0. Alright, then it will start back up again. So this is the what? This is the two types of counters we have. We used a scenario obviously with what? With 3 bits. I started off with 1 to explain what the differences are. Then I went to 2. Now we're using 3 bits. 3 bits can only count up to what? From up to, it can only count 2 to the power of 3 number of counts, which is 8 counts. That is the counts 0 up to 7. If the down counter is 7 to what? To 0. Right, those are the basics for the counters. Let's see if you can try again and try and if we had 4 bits, obviously it will count all the way up. It will count 2 to the power of 4 counts, which is the count what? 0 up to 15, and so on and so forth. So right, let's see if we can continue at a later stage. I hope this makes sense for now. Ciao ciao.